Okay, good afternoon, right, everyone. Okay, so I hope all of you are still okay. All right, so actually we continue. Can you check for me whether we already finished all for the specific latent heat? Did we finish or answer all the question for the specific latent heat? Yes. Okay. So means we can move on to the next one, that is a gas law. Okay. So this is the last subtopic for chapter 4. Okay, so this is the last subtopic for chapter 4. Then if we can finish today, next week we can go to chapter 5. Then we still got one more chapter. Okay. Then after that we just doing revision, and if we have a chance to come back to school, okay, we continue with our experiment, right? Okay, so let's see for the gas law. Okay, so basically for the gas law, okay, so there are three gas law. Okay, so the first one is the Boyle's Law. Okay, Charles Law, and also Pressure's Law. Okay, so there are basically three gas law. Okay, Boyle's Law, Charles Law, Pressure's Law. Okay, so for this chapter, okay, we learn about, you have to explain how does the gas pressure how does the gas pressure can be produced. Okay, and this is for the Boyle's law. You have to know how to state the law, how to draw a graph, and also how to explain the law by using the kinetic theory, and also how to solve problem, okay, using the Boyle's law. This is the calculation, and also be able to explain the experiment, right? So the first thing we have to learn, how does the gas pressure, okay, occur. Okay, so basically the gas pressure is occurred by the collision between the gas molecule with the container. Okay, so you already know, inside of the container, if you put the gas inside of the container, all the molecule gas will move randomly, right? So you move randomly. So when you move randomly, okay, they will collide, okay, collide with another molecule, and also it will collide with the wall of the container elastically. Okay, so later we will see a video, right? So then we collide with another molecule. So for this one, they will start moving. Okay, then maybe it collide with this molecule, then hit the wall, then bounce back. Okay, and then maybe hit another molecule, and then hit the wall and bounce back. Okay, so then we collide with each other, and also at the same time it will collide with the wall container. So every time a collision occurs, okay, so there is a change, all right, in momentum. Okay, so there is a change in momentum. Okay, because there are velocity, right? The velocity, the initial velocity, and then after it being hit back, okay, so there will be a change of momentum. Okay, the difference of velocity, okay, the initial velocity, when it hit the wall, and then it bounce back, okay, that one is a final velocity. So there must be a change in momentum. Okay, so this change of momentum, okay, produce force. All right, the force that we call it as a impulsive force. Okay, so this will produce a force, and then after that we already learned, okay, that pressure is equals to force divided by area. Okay, so every time there is a force, okay, there must be a pressure. Okay, so then when there's change in momentum, when they collide with the wall of the container, they will produce the change of momentum. So this change of momentum will produce the pressure, right? So the pressure is caused by the force, right? The force that produced by the change of momentum there. So the change of momentum produce the impulsive force. So this impulsive force will produce the pressure. Okay, so what does it mean by pressure? So pressure is defined as a force per unit area. Okay, so therefore, right, the pressure of the gas is due to the force of collision of the gas molecule with the wall of the container. Okay, so what is the cause of the pressure is actually due to the force, right? When it hit the wall container, so how much does the force produce? Okay, that is the pressure. Okay, so basically generally what we can say here, Okay, the pressure is actually occur when the when the molecule gas collide with the wall container. Okay, the collision between wall container and also the molecule. Okay, the collision between the wall container and molecule will produce the pressure. So if the collision increase, all right, it means the pressure also will be increased. All right. So that is the how does the pressure produce, right? By the collision of the gas molecule with the wall of container. So when it hit the wall of container, there will be a change in momentum. Then this change of momentum will produce the force. Okay, and based from the formula, P is equals to F over A. So when there is a force, there must be a pressure, right? So basically, generally, we can say that, okay, the pressure is caused by the collision of the air molecule with the wall of container, right? Okay, so let's see for the activity 2. Okay, so it says here to recognize variable which affect the behavior of gas. So let's say if I have a shrink here, okay, and then I close the mouth of the shrink. Okay, so why I close the mouth of the shrink? So this one is actually to avoid the atmospheric pressure. So what is the pressure that only will act on the shrink is only based on the pressure inside of the shrink. Okay, so then when I close the mouth of the shrink, I push the piston into the shrink. So I push, right? So what will happen to the volume, then air pressure inside the shrink? So what will happen to the volume when I push the piston into the shrink? What will happen to the volume? Yes, the volume will decrease, right? So when the volume will decrease, what will happen to the pressure? The pressure increase. Why? Because there will be more collision occur, right? Why? Because the space now becomes smaller. So when the space now becomes smaller, so the molecule cannot move freely. So it will hit the wall of container, okay, more frequently. So the rate of collision between the air molecule, okay, with the wall container there, okay, it will be increased. So when the rate of collision is increased, it means the pressure also increase, right? So here you said just now the volume decrease, the pressure increase, okay? Because why? Now they got not so much space to move, okay? So when there is not so much space to move, they will collide with the wall of the shrink here, okay, more often. So when the collide more means the rate of collision increase, so does the pressure. Okay, so that is what happened to the volume and also the pressure. So recognize two variables which affect the behavior of the gas. So what is the variables that affect the behavior of the gas? Volume and pressure. Okay, volume and pressure. Okay, so that is one example. Okay, that one we investigate about pressures and volume. Okay, this is for this activity. So next one, right? For the next one, I put the test tube. Okay, so inside of it is the air. Okay, inside of the I fill the air inside of the test tube. Okay, and then I put the water here. Okay, it has to be a color water. Okay, and then I heat it. Okay, so what will happen to the temperature and the volume of the air? So what will happen? The temperature increase. And how about the volume? The volume also increase. Okay, how does you know that the volume increase? Does the test tube expand? How does you know that the volume is increased? Based on what? What will happen to the water here? Will it go up or will it go down? Yes, it will go up. Okay, if we go up means the volume, okay, the inside here it push the water here, okay, so if we go up, so means the volume is increasing. Okay, so for this one the pressure is increasing because this one is not volume, this is a temperature and pressure. So because you heat up the air molecule here, right, so what will happen to the kinetic energy inside here? So when you heat the air molecule here, the kinetic energy will increase, so mean it will move faster. Okay, so when you move faster, it will keep hitting the wall, okay, and the rate of the collision now is increasing because it move faster. Okay, just maybe because before this, when you are not hitting the test tube here, it just move like this. Okay, right, but then after you hit the air molecule here, test tube here, so what will happen to the kinetic energy? It will move faster. Okay, so when you move faster, it will be the increase of the rate of collision here, right? So when the rate of collision increase, means the pressure also increase. So when the pressure increase inside the test tube, it will push the water here go up. Okay, because now here the pressure is already increased. So it will push the water going up. So maybe after that, the water will be on this level. Okay, so it will go up. Alright, so for this one, we investigate pressure and temperature. Right, so this one, yes, temperature increase, volume increase. So what is the two variable here? Volume and temperature. I thought this one is pressure, volume and temperature. Supposed to be pressure and temperature, right? With volume, you better use like a balloon like that. You put in the hot water, okay? So then it will absorb, the balloon will absorb the hot water, the heat energy. So now it become expand. Okay, so for this one, you can use volume and pressure and temperature too, right? Okay, so based on these two activities, okay, so we can state the three variables. So what is the three variable? Volume, temperature, and pressure. Okay, so this is how you want to explain, okay, the volume. So the based on the kinetic theory, so it said the volume of the gas is equals to the volume of the container, okay, and also the temperature is directly proportional to the kinetic energy. So when you increase the temperature, the kinetic energy also will increase, right? And for the pressure, okay, so when air molecule collide with the wall container, they rebounds back. So that is a change of momentum and force is exerted on the wall. Okay, so the formula is force divide area is the gas pressure. Okay, so this is the unit. So for pressure is Pascal, symbol is PA, and other unit is cmHg. So this one if you use a mercury, okay. And for the volume, the unit is cm cube, the symbol is cm cube also, and the unit, okay, other unit can use liter, but usually we use cm cube. Alright, and then for the temperature, degree Celsius, but other unit we use Kelvin. But for the gas law, you have to change the degree Celsius to Kelvin. You cannot use degree Celsius in the calculation for the gas law. So every gas law you calculate, okay, you calculate the value for the gas law using the gas law formula, okay, and that's involved in temperature. So you must change the degree Celsius to Kelvin. Okay, so how you want to change? Okay, degree Celsius to Kelvin, just plus 273. Okay, so if you use degree Celsius, your answer is wrong. Okay, have to change to the Kelvin first, then you can put in the formula. Okay, if there's involvement in the temperature inside the formula, like Charles' law and Pressure's law. Okay. So now we go to the first law, that is a Boyle's law. Okay, so let's see a video about the experiment of the Boyle's law before we move on to this one. Is there anything you want to ask? Okay, if you already done your paper one, right? The one that I gave. Okay. There's a one answer. I think the one that you need to find the trust, the engine trust. I think. So that one, the answer should be 2000. Yeah, number 11. So that one should be the answer 2500, right? If I'm not mistaken, 2500 Newton. Okay, so if you got 2500, yeah, it's correct. Okay, because there's no there's no answer in that question. A B C D, no 2500. So if you got 2500, it's correct. Okay, so this is the sample, the experiments of the Boyle's law. So they use a balloon here. Okay, this is the old format, KBSM. Okay, so inside of it, this is air molecule. Okay, then you can see it decrease the volume. Okay, so it decreased the volume here. So when the volume decrease, so inside of here the pressure must be higher. Okay, so let's see the experiment. Okay, all right, so this is actually the experiment. So when you have chance to go back to school, so we do this experiment. So you can see here there is a rubber tube. Okay, rubber tube, and this one is a Bourdon gauge. Okay, this one is a Bourdon gauge to measure the gas pressure. Okay, so this one will be connected to the syringe. Okay, so let's see what will happen. So you can see they use a very short, right, very short rubber tube. Why? Because we don't want to the pressure of gas, okay, to lose to the surrounding and to avoid the leakage of the gas. Okay, so that's why the rubber tube is very short here. Okay. So this is 20 cm cube, and this one is 10 Pascal. Okay, so we reduce the volume from 20 to 18. So you can see there is increase of the pressure here. Okay, 20 cm cube to 18 cm cube. You can see the pressure is increased here. 18 to 16, you can see it increased. So it keep increasing. So this is the experiment of Boyle's law. So it will keep increasing. Right? So this is the experiment for Boyle's law. Okay. And we already discussed this now also, like syringe, right? When we close the mouth of the syringe, right? And then you push the syringe, you already know the volume is decreased, and inside of it the pressure is increased. Okay. So we continue, right? So that is the Boyle's law. So that is the experiment. Okay. So we have to state, right? What is the what is the Boyle's law? So at first we have to investigate what is the relationship between pressure and volume. So the diagram A shows a gas with a constant mass and temperature in a cylinder. Okay, so if you investigate about the pressure and volume, you have to keep your temperature constant. So let's say if you investigate pressure and temperature, you have to make your volume constant. Okay, so for this one, pressure and volume, so you have to keep your temperature constant. So for this one, a load is put on the piston, and then diagram P shows another load is added on the piston. So what is the difference? You can see here the volume, right? So the volume is decreasing. Okay, so the volume is decreasing. So based on the kinetic theory, okay, you have to explain what will happen to the gas pressure. So can you tell me what happened to the gas pressure here? Okay, you have to explain what happened to the gas pressure here. Okay, by using the kinetic theory. So you have to explain about the collision between the air molecule and the wall of the container. Okay, so please write me the explanation. Okay, so let's say if I give you 2 marks for this one. Okay, so what is your answer? If 2 marks, usually you need to have 2 points, okay? Or 2 sentences. If you want to write more, then it's okay. Also can. Okay, so if you answer just like that, you will get only 1 mark. Because you only explain about the collision, but you didn't tell me what will happen with the pressure. Okay, collision of the air molecule increases, so the pressure increase. Okay, so how to answer for this one properly? So you have to state, right? Okay, when the volume is decreased, okay, the rate of the collision, okay, between the air molecule and also with the wall container is increases. Okay, so thus, right, thus the pressure, okay, the pressure of gas inside of the container also increase. Okay, so mostly got of you got it correct. Okay. Alright, so this one is the more proper one. Okay, but in exam, if you answer like that, also you already got marks. Okay, so this one, volume decrease, gas molecule are closer to each other. So the rate of the collision between gas molecule and the wall increase, 1 mark. Okay, and you already said here pressure increase, 2 mark. Okay, so very good. So what is the relationship? So what is the relationship that you can say here? The pressure, no. What is the relationship here between the gas volume and the gas pressure? Inversely proportional. Okay, very good. So the volume is inversely proportional with the pressure. Okay, so when the volume increase, the pressure decrease. When the volume increase, pressure decrease. When the volume decrease, pressure increase. Okay, so this is inversely proportional. Okay, so what does the Boyle's law state here? So it states that the volume of gas is inversely proportional to the gas pressure if its mass and the temperature are constant. Okay, so this one is the Boyle's law. Alright, so what does it mean when it said the mass is constant? Means you didn't add the number of molecule inside of the container. Okay, so you didn't add any number of molecules. So if the molecule number is constant there, so that means it's the mass here. Okay, so mass and temperature are constant. Okay, so that is the Boyle's law. So explain from the kinetic and theory. So this one we already discussed. Okay, collide more often, this one will increase the pressure, right, inside of the wall container. So this is the formula for the Boyle's law. P1 V1 is equals to P2 V2. Okay, so let's say for the first part, okay, for this one, okay, this is the initial condition. Then after that, when I push the piston, okay, so it will be new volume here, right? So both of it is equals. P1 V1 is equals to P2 V2. Okay, so this is the formula and this is the graph. Since just now you said the P pressure is inversely proportional to the volume, so the graph should be like this. Okay, and for P is when the P against with 1 over V, okay, this one is directly proportional. So you have to be careful. What is the axis here? So if the axis is V is inversely proportional. But if you change the V to 1 over V, so it will become directly proportional. Okay, it will pass through the origin here. So this one should be directly proportional. And if PV against B, okay, the value should be constant like this. Okay, so this is the triangle. Okay, the triangle for you to memorize, okay, easily for the gas law. So for Boyle's law, you just close T. Okay, so what is the formula? PV. Okay, so PV. All right, so PV is P1 V1 is equals to P2 V2. Right, so PV is actually equals to the constant. All right, so just close the T, you will get PV. So PV is the Boyle's law. All right, so let's see the this is the activity that you can do for Boyle's law. Okay, this one they use a form. Okay, they use a form inside of this. Okay, then they take out the gas. Okay, so when they take out the gas inside of the jar here, so the pressure now inside of the jar is decreasing. Okay, so when the pressure inside of the jar is decreasing, what will happen to the form here? So it will expand. Okay, it will expand. Okay, because the air molecule is they take out the air molecule, so there is no gas inside of it, right? Then okay, when it put back the gas is the gas inside the jar here, now the pressure inside the jar is increasing. Okay, so the pressure increasing, it will push down the foam. Okay, then go back inside the beaker here. Okay, because outside here the pressure is increasing, so we push down the foam. Okay, and we go back to the beaker here. So this is one example of the Boyle's law. Okay, so this is the activity, right? Okay, so let's move on to the next one. Okay, there's one they use a marshmallow. Okay, okay. So this one also same, but that one they use a form. This one they use a marshmallow. Okay, so when you take out the gas molecule here, so inside of it, there's the number of gas molecule is decreasing, right? So when it decrease, you can see the pressure is become lower inside of this jar. Okay, so this one the marshmallow will expand. Okay, it will be expand. Okay, then after that, when it put back the gas molecule, so here the pressure is increased inside of the jar. It will push back the marshmallow to go back to its original condition. Okay, so that's the activities for the Boyle's law. Okay, and another one, okay, there's one they put the small balloon, okay, inside of the syringe, okay. So this is the video. Hmm. So here you see the volume is increasing, right? So after that, when you push the piston, the volume become decrease. So the volume decrease. So inside of here now the pressure is higher. So you have to see what will happen to the balloon, the size of the balloon there. You see the size of balloon becomes smaller. Okay, so the size of balloon becomes smaller because of what? So outside here the pressure is become higher, so it will push the balloon, okay, and it becomes smaller. Okay, so this is the pressure and volume. This is also the activities for the Boyle's law. Okay, so see when it increasing the volume, okay, the ball go back, okay, to its original position. Okay, let's try for this question. Okay, this one, solve problems regarding Boyle's law. So I give you time to find the answer. So this one you use P1 V1 is equals to P2 V2. So you have to calculate the pressure and the volume, okay, before it being released, okay, to the sky, okay. So this is before it release. Okay, before release, this is after release. So what is your pressure here and what is the volume here before it released and after it being released to the sky, right? What is the pressure? Okay, and it's already stated that the volume is decreasing. Sorry, the volume is increasing. So what's the answer for this one? 0.25. 0.25. Can you give me how do you use your formula? What is the value that you put in the formula? Thirty plus 1 times 1. Okay, so correct. Right, very good. So pressure here is 1 atm, right? 1 atmosphere. So 1, okay, times the volume is 30 liter, right? And then the pressure is the one you need to find after it release and already said the volume is 120. So P2 is 30 divided by 120, so you will get 0.25 atm. Okay, so let's check whether it's correct or not. Yes, okay, 0.25 atm. Okay, how about this one? Okay, this one I give you a clue, right? So when it's inside, when it's inside the water, okay, there are two pressure acting on the bubbles. Okay, the first one come from the atmospheric pressure, okay, and the second one it comes from the pressure and from the water itself. So there are two pressure that acting on the air bubble when it's inside of the water. The first one, atmospheric pressure. The second one is the pressure from the water itself. Okay, so this is the air bubble when it at the surface of water, and this one is inside of water. Five point two five. 0.25 cube. Okay, so there are two different answers. Others? Maybe you got another answer, or maybe you are same like Kenya or Shuanki. Ziyin got 0.25 also. Okay. Others you want to try, the one that very quiet. You know, if you answer like this, and then I can recognize your name, right? So when I can recognize your name, so when I see your PBD and I see you always, you are very active in the class, okay, and you try to answer, okay, and even it's wrong, I mean, you are trying to answer, I will help you, for your band. Okay, if you like keep quiet and then also at the same time you didn't submit your work to me and even you submit it's late, okay, then I cannot help you, okay, because all of this will be a proof, okay, a proof for you to answer, sorry, a proof for your PBD, okay. Just answer, is it wrong? It's okay, I mean, you are trying, at least you try. Okay, 0.25, 0.25. Okay, so let's see how to answer for this kind of question. Okay, so use the same formula. This one also P1 V1 is equals to P2 V2. Okay, so for the first on the left, okay, on the left the formula I put this one is the pressure inside the water. Okay, and this one is on the surface. Okay. Alright, so let's see inside the water here. So I already tell you there are two types of pressure, okay, that are exerted on the air bubble here. The first one come from the atmospheric pressure, and the second one come from the water, the pressure of water. Okay, so means you have to add these two pressure. Okay, so the atmospheric pressure already give to you 10, right? So 10 plus, okay, what is the pressure in water? So you can see here it already state 0.5 meter. You can see the unit for the atmospheric pressure also in meter. So means 0.5 is actually the pressure inside the water. Okay, so you have to add with 0.5. So 0.5 is actually the pressure for the air bubble inside the water. Okay, that exerted by the water, right? And 10 is by the atmosphere. Okay, and the volume there is 5 cm cube. Okay, and then when it goes to the surface there, okay, only one pressure that acting on the air bubble now. That is atmospheric pressure. So this one P2 is 10. Okay, then you have to find V2, right? Okay, so this is 10.5 times 5, and this is 10 V2. Okay, 10.5 times 5 is, so I think Shwanki got correct, 5.25. Okay, very good, Shwanki. Yeah. So can you understand how do I get 5.25 for those who answer 0.25? If you answer 0.25 means you didn't add the atmospheric pressure, or you didn't add atmospheric pressure, is it? Okay. So I did tell you when inside of the water you have to add two pressure. That means there is atmospheric pressure and also the pressure come from the water, right? So just add on both of it, okay? And then you got the answer. So let's see whether it's correct or not. Yes, 5.25. Okay, how about this one? So this one they use a tube and then they put the mercury inside the tube, okay? And for this one they put it in the vertically, okay? Sorry, horizontal, okay, and then it turns to vertical. Okay, so this one also use the P1 V1 is equals to P2 V2. Okay, so this one, let's say this is for horizontally, and this one is when it's vertically. Nine 9.62 cm, is it? 9.62. Okay, any other answer? Maybe you got a different one. Can I know how do you get 9.62? How does you substitute in the formula? What is the value that you put in P1 V1 and P2 V2? Yes, very good. 75 plus 3. Okay. Hmm. Alright, so How do you get 75 plus 3? Can I know? How do you know that you have to add plus 3 there and that one you don't need to add? For those to answer 75 plus 3. The pressure from the mercury. And another one is the pressure from the 75, the pressure from the, yes, very good, Shonji. Okay, so for this one, 70 for the horizontally, okay, because for the horizontally, there is no force, there is no pressure that acting on the mercury. Why? Okay, actually this one come from the gravity force. All right, so there is no way for the gravity force to pull the mercury downward because it's in the horizontally, right? Okay, let's see for this one. Okay, but for this one, okay, there's a chance, okay, for the gravity, okay, to pull down the mercury, okay, to pull down the mercury and also to pull down the atmospheric pressure, okay. So that's why, okay, we have to add 75 plus 3 here. This one only 75, okay. So 75 multiplied by 10. Okay, and for this one, okay, there is a force of gravity here, so there are two forces that acting. The first one come from the mercury, the pressure from the mercury, and the second one come from the pressure of the atmospheric. Okay, so 75 plus 3. Okay, so V2. So what the answer for V2 is 9.62 cm. Is it correct? Yeah, 9.6 or 9.62. Okay, how about this one for number 4? Okay, anything you want to ask teacher for number 1 until number 3? No. Okay, that one because 75 plus 3. So there are two pressure that acting on the volume there. Okay, it push down the volume. The first one come from the atmospheric pressure, right? And the second one come from the pressure come from the mercury itself. So you have to add plus 3. The one that the horizontal, okay, so only the atmospheric pressure that can add on the horizontal tube just now, okay. And mercury because there is no force that acting pull it down, right? Because it's now I said there is a force of gravity, so there's no way that the gravity force can pull down the mercury downward, right? So for atmospheric pressure you cannot do anything because the tube is the opening surface, so everything that the surface is open, okay, that means there must be a atmospheric pressure. Teacher, this one already got answer in the paper. Oh, really? Maybe I forgot to to delete the answer before I print. Okay, all right. So actually for this one, using never mind, I just explain, all right? So P1 V1 equals to P2 V2. Okay. And this one it says diagram A, right? Okay, for diagram A is 6 centimeter cube of air. Okay, is trapped, okay, by a mercury. Okay, so for diagram A, the pressure is only the pressure that acting on the mercury is only atmospheric pressure, right? So 75. Okay, for this one. Only 75 and then times by 6. Okay, this is the volume. Okay, and Diagram B, okay, add 150 cm, okay, of the mercury. So means you have to add 150 plus 75, okay. The atmospheric pressure, now you have two pressure, atmospheric pressure and also the pressure comes from the mercury, okay. So you will get, need to find V2 here, right? So what is the answer? 450 divided by 225. So you get 2. So your answer is 2. Okay. Is it okay? Okay. So if any question you can ask, right? So let's go to the Charles law. Okay. So before I go with the Charles law, we see first the experiment. Okay, for the Charles law. Okay, so this one is actually this one we will not do this one at the lab. Okay, this one is actually the activity. The experiment one, you need to use the capillary tube. Okay, capillary tube, then you put inside of the beaker, right? Okay, and then you will heat up the beaker. Okay, and then the round bottom flask. Okay, then you will see the length of the capillary tube there will increase. Okay, but I think I got one. Wait, can you wait for a while? So I think we cannot finish gas law for today. Mm, wait. I already find this now. Mm, wait. I saw someone they're using a kettle. Yeah, yes, this one. Okay. Mm, okay. Actually, this is the experiment that you have to do in the lab. Okay, but this one, they use a kettle. Okay, they use a kettle to heat up. Okay, to heat up the capillary tube. So we see this is the experiment that we should do. Okay, so this is the capillary tube, right? And this is the kettle. So this one to replace the, if not, we have to immerse, okay, inside of the water, right? So for this one, they just replace the beaker with the kettle, okay? So this is the capillary tube, okay? And beside it is a thermometer, so it's easy for you to read, right? So this is the length of the capillary. So you will see whether it's increased or decreased, right? So they got skill there. So this one is what we have want to do is actually to, okay, so they put inside the kettle, right? Wait, I thought just now I saw it hit the kettle. Sorry, wait for a while. I found another one. Sorry. Hmm. Okay, never mind. When I found it, I will show to you in the next class. Okay, just now I found it, but I don't know, I forgot to bookmark uh, the video. Okay, so sorry. Okay, so for the Charles law, okay, so never mind, we see the experiment just now. It's also explain the Charles law, but that one is not the experiment, that one is just for activity. Okay. Okay, so for this one, they use a balloon and the hot water. Okay, they use a balloon and the hot water. So you can see here, okay, it shows this. Okay, so this is the balloon, right? And it closed the beaker here, right? So that means there is no heat loss to the surrounding. Okay, so here the water will transfer the heat energy to the balloon, right? So the balloon uh, will become hot. Okay, so when it become hot, so inside here, right, the temperature is increasing. Okay, inside of the balloon, the temperature is increasing. So and then when it become hot, you already know when you heat the air molecule, the kinetic energy here will increase. So the velocity here is increasing. The velocity of the air molecule increasing, so it will hit the wall of the balloon here. Okay, it will increase the rate of collision between the air molecule and the balloon here. So the pressure inside of it will be increased. Okay, so let's see what happened to the balloon here. So you can see it expand. Okay, so this one is also to prove for the volume and for the temperature. Okay, then after that we put in the freezer. Okay, so you can see the size of balloon, it become smaller, right? So this is the activity that you can do to prove the Charles law. Okay. Okay, so I think for this one I will continue on the next class. Okay, and we still got two more slots. Alright, so I stop until here. Okay, so I will assign a new work for the Google Classroom for paper 2. Okay, so for those who still didn't submit for paper 1, please submit. And on Saturday, we will discuss about paper 3. Okay, there's a lot of mistake for paper 3, and also for the structure, no, for the essay question for 4.2. So we will discuss on that one. Alright. Okay, so make sure you submit first. Okay, you turn in to me first so I can mark first your paper, then we can discuss later. So if you have any question, you can ask on that day. Okay, so see you on Saturday at 2 p.m. Right? So thank you, class. Okay, have a good day. Take care, everyone. Bye. Bye.